Hello students, today we are going to start on theoretical and experimental probability. Let's go ahead and get started. The price wheels for a carnival game are shown. You receive a less expensive price if you spin a win on wheel A. You receive a more expensive price if you can spin a win on wheel B. Let's investigate the probabilities of winning on either wheel with the respective price amounts. So if you take a look at wheel A, you got an evenly spaced you win, you lose part. But if you look at wheel B, you have like the you win sections are a lot smaller. All right. So okay, let's move on here. In an informed probability model, each outcome has an equal probability of happening. So if you look at wheel A, does it have an equal probability of happening? Does every one of them have an equal probability? Yes, you can see it here clearly. But here, you can't, because it seems like the you win part is a lot smaller than the you lose part. So if we continue here, which wheel has a uniform probability? Well, we see here that it's wheel A, right? Use a paper clip and the tip of your pencil to spin each wheel 4 times. Record your results in this table. So the way you're going to do it is that you're going to put your pen right here, and your teacher will distribute some paper clips. So you put the pen there, and then you just spin it, and then you can see how many spins you get, and then you will put it here. So spin number 1, wheel A, what did you get? Spin number 1, wheel B, and then you're going to fill out this formula, okay? So we can pause this video to complete this section when needed. 2, use a paper clip and the tip of your pencil to spin each wheel 4 times and record your results. Why do you think winners on wheel A receive a less expensive price than winners on wheel B? Okay, so go ahead and pause the video and have a discussion on why do you think what would be the answer for this and your best probability or why the difference is. All right, let's go ahead and go to page 380. Okay, experimental and theoretical probability. Theoretical probability is based on uniform probability. What should happen when conducting a probability experiment? Okay, so this theoretical is basically, if you can see the root word here, is theory. So in theory, in a perfect world, I mean, this would happen. The mathematical part, theoretical. Is, let me see, the mathematical probability. Okay, so basically it's what we, if everything was in a perfect world. Okay, now experimental probability is based on relative frequency, and you saw that word in the previous video, how often something comes out, what actually occurs during such an experiment, what actually occurs. So when you actually do the actual experiment, the theoretical probability and the experimental probability of an event may or may not be the same as the number of attempts increases. The theoretical probability and the experimental probabilities should become closer in value. So what this means to you is that if you know that a coin is 50, so the probability of getting heads in a coin is 1 out of 2, right? That means that the more you flip a coin, the closer you're going to get to this. So if you flip the coin once, you might get 1 head, right? If you flip it twice, you might get 2 tails or things like that. But let's say if you were to flip the coin a lot of times, your average would probably come down to 1/2. So this is what all this paragraph means, that the more you do the experiment, the closer your experimental probability gets to the theoretical probability. And you'll see that as we do experiments while we go through this lesson. Example number 1. The graph shows the results of an experiment in which a spinner with 3 equal sections is spun 60 times. Determine the experimental probability of spinning red for this experiment. Predict how many times the spinner will land on red if it is spun 500 times. Alright, so let's begin here. Step 1. The spinner landed on red 24 times, on blue 15 times, and on green 21 times, as you can see in the graph right here. Alright, so the total number that they spun it was 60 times. So this should add up to 60. So the probability of red was the number of times red occurs. So where is red? 24. So 24 goes on top. The total number of spins was 60. So it's 24 out of 60, which reduces to 2/5. So 2 out of 5 times you will get red. The experimental probability of spinning red is 2 out of 5. Okay? So here we go. Step 2. Suppose the spinner was spun 500 times. Predict how many times the spinner will land on red. Well, you know that if you spin it 60 times, or if you spin it 5 times, you're going to get 2 out of 5 if you spin it 5 times. Then from here, you set up a proportion, basically, of how many would you do if you run it 500 times. Okay? So now here you can obviously see that if you multiply this times 100, you get 200 here. So basically you get 200 out of 500, which actually reduces down to, if you were to cover up, cross out the zero, it's the same thing as 2/5. So basically that's what you would get. Alright, now here, what this means here is that you multiply 2/5 times 100, means you multiply the top and the bottom. So you can get this. Or another way you can do it is you multiply 2 times 500, which will give you 1,000, and then divide it by 5, brings you back to 200. Okay? So,
Gabriel, this female, please report to the front office for a bus pickup.
alright, sorry about that, guys. I tried to pause it, but it wasn't fast enough. Okay, so let's continue. With this information that you just learned here, you should be able to answer the questions that are down here. So all this refers back to the spinner in example number 1. Okay? So let's go ahead and go to page 380. 381, I mean. On page 381, example number 2. It says here, 2 number cubes are rolled together 20 times. A sum of 9 is rolled 8 times. What is the experimental probability of rolling a sum of 9? All right, so now we're talking about if when you add up the 2 dice that you get, that they add up to the number 9. All right, so it says here, well, how many ways can you get a 9? Yes, and it says here that you could get the total number of times of some 9, okay? So here we go. It was rolled 20 times, and they got 9, the sum of 9, 8 times. So 8 times out of 20, which simplifies to 2/5. So the experimental probability of rolling a sum of 9 is 2/5. All right? So this is exactly how you will find the experimental probability if you actually roll the dice. This right here. And so now let's continue with example 3. Compare the experimental probability you found in example 2 to its theoretical probability. If the probabilities are not close, explain a possible reason for the discrepancy. So here we go. When rolling 2 number cubes, there are 36 possible outcomes. The theoretical probability of rolling a sum of 9 is 4 out of 36, or 1/9. All right, so if you look at the table here, rolls with sum of 9. Here are the total possible ways that you could get a 9. A 3 and a 6, a 4 and a 5, a 5 and a 4, a 6 and a 3. This is only 4 possible ways that you could get it out of 36 tosses, which simplifies to 1 out of 9. Okay? So if we continue here, it says, since 1 out of 9 is not close to 2/5, the experimental probability is not close to the theoretical probability. One possible explanation is that there were not enough trials. So if you think about it, and we were to, let's say, double up the trials to 72, you know, you might get closer to your 2/5. All right, so that's for, as you can see, like when we did in the lab, the more trials you do, the better possibilities that you get to the actual theoretical probability. Now, that should get you good enough. That should be good enough information so you guys could do the goddess on this problem, okay? In example 2, what is the experimental probability of rolling a sum that is not 9? Well, for this you already know. Well, what's everything else that's possible? So if you go back here, it's 4 out of 36, then the other part should be 36 minus 4, which will be 32 out of 36. The part that you don't want, which will be the sum of 9s. So you don't want any of these combinations here. You want everything else but those combinations. All right? So let's go ahead and go to page 382. Last example here so you guys can understand here. Now, here's where it gets a little more complicated. Predicting future events. Theoretical and experimental probability can be used to make predictions about future events. Multi-step example number 4. Last year, a DVD store sold 670 action DVDs, 580 comedy DVDs, 450 drama DVDs, and 300 horror DVDs. If a media buyer expects to sell 5,000 DVDs this year, based on these results, predict how many comedy DVDs she should buy, and then explain your answer. Well, let's go to step 1 here. 2,000 DVDs were sold and 500 were comedy. Okay, where did we get this 2,000? Well, this 2,000 comes from adding up your action, your comedy, your drama, and your horror. If you add that up, you get 2,000. Out of those 2,000s, 580 right here were comedy. So here it is. So then the probability of the probability there was 580 out of 2,000. Or if you simplify this, you get, if you divide this by 20, both top and bottom, you get 29 out of 100. So now we're going to use this number, 29 out of 100, use this to make your prediction. So if you were to sell 29 comedy DVDs out of 100 of the total DVDs, then how many comedy CDs would sell if you were to sell 5,000 of all DVDs? So this is where we set up a proportion. So if you could sell this many comedy in this many sales, then how many comedies would you sell in this many sales? So once again, we cross multiply and divide here. 29 times 5,000 is 29 times 5,000, and 100 times x becomes 100x. Now we divide by 100 on both sides. This cancels. Oh, well, there it is still. Let's do it right here. Divide by 100, divide by 100. Okay? So this cancels. X is equal to, let's see, let's cross out 1 0, 2 zeros. 1,450 divided by 1 is just 1,450. So then what this means is that she would have to buy about 1,450 comedy DVDs out of the 5,000 that of all the DVDs possible. All right, so go ahead and pause the video every time you have a question or when I'm explaining something in here, guys, because it's a lot of information and you need to know where all the numbers come from, okay? So remember, probability is usually the favorable over the total. So in this case, what the favorables that where they wanted was the comedies out of the total of 2,000 DVDs, and that's where everything starts. You just happen to simplify it because this number is easier to handle than this fraction here. Now imagine putting this fraction right there and trying to convert it into 5,000. It's possible, but it creates a little bit more work. Okay, guys. You guys are ready to continue on your own from here. The rest we'll have to work on it in class, okay? So, good luck.